the last video we have done the condensation of the carboxylic acid and hydroxyl group. We're going to look at what will happen if you are actually reacting the amino acid with an acyl chloride. Acyl chloride is a derivative of the carboxylic acid, and it will react with the amine group, just like in the normal alpha amine when they are connected with one carbon atom. Now, if you look at this one, you have two amino groups there, and both will actually react with the acyl chloride, and both will undergo the condensation reaction, and you will see that it will be a new link which is not entirely as like a ester group. So this NH2 there, both of them, I can actually write them like that. So each of this go from acyl chloride, so this one will be negative and carbon will carry positive charge. That part will actually combine with the NH2 NH there, and also there. So here you will have NH, then you have carbon there, double bond CH3. Over there, this carbon which has an R group with an amine extended, this will be NH, and it will combine with the CO bond, and that will make the rest of the molecule as it is. In both cases, you will see you have NH-CO bond. So whenever you see NH, which is the CO bond linkage, that linkage is called amide linkage. It is not same as ester, but the name is amide linkage. Now, if I want to look at the hydrolysis of, as I said, because this is actually obtained from one of the derivative was actually carboxylic acid, and whatever the reaction has done and produced at the end, if I try to do the acid hydrolysis or alkaline hydrolysis, this bond will break automatically. And if I remove this, if you want to take a screenshot, you can do that. And I will remove that and will do an acid hydrolysis. The reason we do acid hydrolysis because the water is not a very good proton donator, so we need to use the acid to produce some extra proton for us. The moment you're gonna put the all of the new molecule with the amide linkage into hydrolysis, this bond will break, and that will reproduce the carboxylic group, because the HCl is actually be removed as a product. So now this will produce the molecule as it is. So this will actually reproduce, and rest of the molecule will be 2CH3 COH will produce as well as a result of that. So the alcohol will be produced in the same way. What I was thinking to talk about is today the optical isomerism as well. I'm not going to go into the details. There's a separate lecture about the enantiomer and stereoisomerism, but all I want to talk about is the optical activity. So the amino acids, they actually show the optical activity. Now, amino acids, if you look at it, when there are two different rules for that. Number one, the carbon atom should be connected with 4 different groups. So you have 1, 2, 3, 4. So that carbon will be known as chiral carbon. And the mirror image should be non-superimposable on it. So if you look at this one and you put a mirror in front of it, this CH3 will come on this side as like that, and you will have hydrogen there, and then you will have C2H5 on the other side. It's just like the rule like that. But if this is my hand and I put my hand like that in front of the mirror, you will see that the mirror image will appear like that. If I put my hand on top of my my mirror image, both of the thumb will be in the different directions. That means the mirror image is not superimposable on this on the mirror image. That type of molecules will show the optical activity. That means they will actually change the direction of plane polarized light. Now, because there are two different ones, if one will be positive, and they are called enantiomer as well. One will rotate the plane polarized light in the positive direction, that is clockwise. One enantiomer will actually rotate the plane polarized light in the anti-clockwise direction. So these two are present in the solution. Their physical and chemical properties are same for both of the enantiomer, and the optical activity can show 50%. So if you have the two enantiomers which are present in the same amount of concentration, so that will be known as a reciprocal mixture, and that will turn the half of the plane polarized light in one direction and half on the other, and that is called reciprocal mixture. So if you do like my videos, if you do like my lesson, can you please make sure that you share my video, follow up, and I will actually upload the next lesson on the polysaccharide. Thank you. Have a good day.